In this video, we'll use the functions IMREAL, MLN or the logarithm, and IMPOWER to generate the complex logarithm and its Taylor-Maclaurin series sum expansion. We begin with the values of V and W. So data validation, list of items from -2 to +2. So we can start with -2. Likewise, -2 for this. And the data set, we begin with the complex part. So complex, the real part is 1 plus Vx, V times X. Now the imaginary part, that is W times X. That's the imaginary. So Wxi. Then enter. Continue. The logarithm of this. So you take the logarithm. So IMLN. And finally, we want the real part. So this will be IMREAL. That's IMREAL. And this is an array formula. So type array formula. And we'll chart this. And we use scatter chart. And show the trend line. The type, polynomial. The degree, 8. For the legend, use the equation, or the label, use the equation, and the legend position at the bottom. So here's a trend line and polynomial of the complex logarithm. Next, we continue with the Taylor series expansion, which is the real part of the logarithm, the complex number, minus the summation of a over x to the power n. And the value of n is from 1 to infinity. And the value a is array formula, or we start with the complex. So complex of v, comma, w. That's the complex. And this is raised to the power -n. So we use IMPOWER. It will be IMPOWER to the power n. So n will be from 1 to infinity. And finally, we want the real part. So this will be IMREAL. But the power is -n, so we put the negative sign. And this is the real part. So IMREAL. Now that we have the real part, we continue with the denominator of we complete the numerator first. It's multiplied by -1 raised to the power n. And now that we have completed the numerator, we continue with the denominator. So divided by n. Now we complete the array formula. So this is an array formula. This will be array formula. Array formula. Now we continue with the series sum. So first we begin with the complex part. So the first item, so complex, that's v times x. So v times x. Now the imaginary. The imaginary is w times x. So w times x. And from here we take the logarithm of the complex number. So we use IMLN. But we want the real part. So IMREAL. And now that we have this, we subtract with the series sum. So minus series sum. So series sum of a over x to the power n. So that is 1 over x raised to the power n, where n starts from 1 incremented by 1. And the coefficient will be this range. And this is an array formula. So we use array formula. That's array formula. These values are exactly the same, but we need to show the polynomial as well. So edit chart, customize, series, trend line, the type polynomial, the degree 8, and for the label use the equation. Now we have the equation. We calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix. Starting with the power, we have the power 1 to 8. Now the elements of the matrix, array formula of the x values raised to the power 1 to 8. And enter. Now we start with the function itself, the complex logarithm. So LINEST dot y and dot x. Likewise, we have also LINEST dot y, comma, and this is dot x. And we compare. So coefficient of x, or x to the 0, 1.04, negative. Coefficient of x, 2.82. Coefficient of x squared, 1.32, negative 1.32. Coefficient of x cubed, 0.424. Coefficient of x to the 4th, 0.0888. Coefficient of x to the 5th, that's 0.0119. And coefficient of x to the 6th, x to the 6th, 9.93 times 10 to the minus 4. X to the 7th, 4.65 times 10 to the minus 5. X to the 8th is 9.34 times 10 to the minus 7. Suppose I change these to 1. I should change this to 1. I can change this to negative 1. And I'll change this to negative 1. I'll change this to 0. I'll change this to 0. Change this to 0. And change this also to 0. And this is all 0. Change this to 1. I'll change this to 1. And they're the same. Change this to positive 1. I'll move the red one upwards. I'll change it to 1. Now they're the same. Change this to 2. I'll change this to 2. Now they're the same. Change this to 2. I'll change this to 2. This computes the use of IMREAL, the complex logarithm, MLN IMPOWER, complex power of the complex numbers logarithm dataset.